All right, number 23. I actually started this one in class. Hopefully you got it. I have the square root of 5 and 2i. Remember with the conjugate theorems, if I have a square root, I'm also going to have the opposite of it. Okay, so I have a positive square root of 5, so I need a negative square root of 5. And then this is a negative 2i. So now when I put these together, I'm going to have x minus the square root of 5 times x plus the square root of 5 times x minus 2i times x plus 2i. And remember, I have a minus b, a plus b, so it's going to be the square of the first minus the square of the second. So this is x squared minus 5 times x squared minus 2i squared is 2i squared is 4i squared, which is negative 4. So minus a negative 4 gives me a positive 4. I hope I didn't do that too fast. Hopefully you followed what I just did. Okay, so now I've got x squared times x squared is x to the 4th. X squared times 4, 4x squared, minus 5x squared, minus 20. So I have x to the 4th minus x squared minus 20. Yep. Okay, changing pace again. Number 24, state the transformations and sketch the graph of the following functions. This is where things can get a little dicey, especially when we're graphing, because we want to make sure that we get at least a few points that are exact. Okay, so what's happening here? Well, we have a vertical shrink by 1/4, and we have a shift 2 units to the left or right? To the left, right? Because it's x minus a negative 2. Okay, and so what I did when I did this problem, we know basically what it looks like. We know it's going to be a parabola because it's of degree 2, and I just plotted a few points here. So I have negative 4 and 1, negative 3, 1/4, negative 2, 0, negative 1, 1/4, 0, 1, and 1 and 9/4. Okay, but these up here are going to be plenty. So negative 4, 1, 1, 2, 3, 4, 1, negative 3, 1/4, negative 2 is 0, negative 1 is a 4th, and then we've got a 0 right here. So it's a parabola, but because it's a 1/4, it's opened up a little bit more. Okay.
Cameron Watcott, if
Wow.
you're in the building, please dial 3510. Cameron Watcott, thank you.
Okay, number 25. We definitely have a shift 1 unit down. Shift 1 unit down. Okay, but what's happening here? When we have just the x that has a negative in front of it, then we have a reflection over the y-axis. Okay, so again, I'm just going to plot some points, and this one, okay, remember, I can know basically what this looks like. So negative x to the 3rd, I can rewrite this as negative x to the 3rd minus 1. So it's basically going to look like this. But I plotted some points. I've got negative 2, 7, negative 1, 0, 0, negative 1, 1, negative 2, 2, negative 9, and I went on and did 3, and it was just really big. So I wrote big. So negative 2, 7, 1, 2, 3, 4, 7, negative 1, 0, 0, negative 1, 1, negative 2, and 2, negative 9, which I think is clear down here. Okay, so now this one looks way more loopy than this one, but that's basically what it looks like. Although it probably is a little loopier. If you wanted to find points, more points in here, you could to see more how loopy it is, but I don't want you to have to worry about that. Okay, I know some people are still really confused on these. I hope that watching me do these will help you get them a little bit better. I promise the more you do them, the easier it gets, and we'll see these periodically throughout the school year. Okay, so write a rule for G that represents the indicated transformations of the graph of f. So here's f of x. That's the same thing as graph of f. Okay, f of x is x cubed plus 5. We're going to do translation 2 units to the right. Now remember, that is the same thing as a horizontal shift. So I'm going to take my x and replace it with x minus 2. So I've got x minus 2 cubed plus 5, followed by a reflection in the y-axis. Remember, that is f of negative x. So I'm just going to replace a negative x for the x right here. So my new g of x, my new transformed function, is going to be negative x minus 2 to the third power plus 5. All right, second one, vertical stretch by a factor of 2. Remember, that's when I take the function and I multiply the whole thing by my factor, whether it's a stretch or it's a shrink. Okay, so I'm going to multiply this whole thing through by 2. So 2 times x to the 4th minus 3x plus 1. That gives me 2x to the 4th minus 6x plus 2, followed by a translation 2 units down. Okay, that means I just subtract 2 on the very end. Okay, the up and down ones are the easy ones. So I'm left with g of x equals 2x to the 4th minus 6x. All right, I will continue with number 28 in the next video.